Right, today, before we go into how matter can change both physically and chemically, we want to look very quickly and review how matter is classified. And we know that everything is made of matter, and matter has two general classifications to begin with: pure substances and mixtures. Elements and compounds fall under pure substances. They both are either found as an element in nature, or they are found in compound forms like the examples given of water, H2O, and carbon dioxide, CO2. And then mixtures we know can be homogeneous or heterogeneous. The heterogeneous ones, you can see all the parts. The homogeneous ones are going to look the same throughout. So the definition of a pure substance is anything that cannot be separated by physical means, such as distillation, filtration, or chromatography. It's going to include your elements and your compounds. So we cannot break them down physically, and we're going to talk about what that physical is as we get to our notes today. Distillation would be you're separating it using heat. So if I want to remove the salt from salt water, I would heat it up, let the water evaporate, and then I would be left with the salt crystals. Filtration, every time your mom cooks pasta and she pours the pasta and the water through a strainer to separate the two, that is a form of filtration. And then chromatography is a way we can separate ink to its color. And I'll pass around an example of chromatography where I broke down some ink into its component colors. And you know that. You know black is made of several colors. Green is blue and yellow combined. So you're just breaking it down into its original parts. We know that an element is made of only one kind of atom. They're found on the periodic table. There are 118. And here are just some of the examples: iron, oxygen, lithium, and boron. We've defined a compound as anything that's elements that are chemically combined. They're written in ratios with chemical formulas: NaCl, H2O, CO2, NH3. Any of those compounds. Salt is not salt if it's not the ratio of 1 sodium to 1 chlorine. We're not talking about water if it's not 2 hydrogens and 1 oxygen. In fact, 2 hydrogens and 2 oxygens is peroxide. So those formulas, those ratios matter in what the compound is. When you form a compound, you've got all new chemical properties. For example, sodium, we saw last week, is a member of the alkali family. That family is very explosive with water. Chlorine is a poisonous gas. It will destroy and kill bacteria. But yet when sodium and chlorine chemically combine to make salt we put on our food. So it doesn't explode. Ocean water is not exploding with the salt in it, and it's not poisonous to us either. So when they combine, they get all new chemical properties. And then again, a mixture is not a chemical reaction, is not taking place. Mixtures can easily be separated back into their original parts. And we've said that the two groups are heterogeneous and homogeneous. So today we want to talk about what this idea of what a physical and a chemical change is. So if matter changes physically, you're not making a new chemical formula. It's probably going to change color, so it's going to look different. It may change states. It may go from a solid to a liquid, or a liquid to a solid, or a gas to a liquid. That would be a physical change. But for example, ice. Ice is solid water. When it melts, it is liquid water. When it freezes again, it is still solid water. It never loses its chemical formula of H2O. Another example, if I step on an aluminum can and crush it, it's taken up less space, it's changed in appearance, but it is still a metal can. If I light a candle, the wax begins to melt. It's gone from the solid to a liquid state, but that wax that's running down the side of the candle is still wax. It's just now liquid. If I chop a piece of wood into smaller pieces, still wood. If I cut a piece of wire into smaller pieces, still wire. It's not chemically changed. That a chemical change is always going to happen when one type of matter is reacting with another type of matter, and you're forming a new substance that has a brand new chemical formula. So when water reacts with oxygen and forms hydrogen peroxide, H2O2, that is a new substance that has all new properties. And in a few minutes, we're going to do some demos to see the difference on these, and then I've got some more to show you on Monday to let you figure out. When I cook an egg, a chemical reaction takes place when the heat is added and the protein changes, and we've got something totally different. Iron. I drop an iron nail into some water. A few days later, you've got flakes of rust all over it. That rust formula is H2O3, so you've made something new. If I bake a cake, a chemical reaction takes place. We add the baking soda and the baking powder to the flour and the sugar and the eggs and the milk, and that causes a reaction to take place. Carbon dioxide is produced. The cake rises. All new chemical properties. I burn a piece of wood. That burning reaction takes place. We're releasing smoke, and we've got ash left at the end. We've got all new products. If my silver tarnishes and turns black, that is silver oxide, that black stuff that is on the silver. That is a chemical reaction. So in all of those cases, one type of matter reacted with another type of matter to form something new. So the chemical formula is going to change in a chemical change. It does not change in a physical change. So how can I look and recognize because I can't see the chemical formula changing. I mean, that's just the numerical math. So I'm going to look at some things that I can observe to see if a chemical formula changes. The first one is an evolution of a gas. So when two forms of matter react with each other, evolution just means produced. Was a gas produced? So that would be one example. Now, heating a single substance and it changing to a gas, that's not a chemical change. But if two types of matter react together and produce a gas, then it would be a chemical change. And we're going to do, again, a couple of demos in a few minutes to show the evolution of a gas. The evolution of light. Is light produced in the chemical reaction? Is heat produced in the chemical reaction? Or does the heat go down? Is there a temperature change up or down that occurs when the two types of matter interact with each other? Is there a color change? And again, a color change may be evidence of a physical change. So you have to, is it one type of matter that the color is changing, or is it two types of matter interacting with each other to cause the color change? And is a precipitate forming? And a precipitate is just when an insoluble solid, something that won't dissolve in another liquid, is produced in the chemical reaction. So usually occurs when two liquid chemicals react with each other and this solid forms during the reaction. So those are the things we're going to look for. Now we're going to stop our notes here, and then as you can see over on the right side of your notes, you've got 4 demos. So you're going to be looking for evidence as we do these demos that a chemical reaction is taking place or a physical change is taking place. So let's do the demos and see.